computer. Okay. So is it recording? Not sure. Yeah, it is recording. Okay. Okay. Hi everyone. Can everyone hear me and see my screen? Yes. No. Hello. Okay, sounds like yes. Okay, let's start. So let me introduce myself first. My name is Pavel Terenin, and I'm a software engineer with more than 12 years of experience. I work mostly on web development, focused on front end, but also doing lots of stuff, full stack stuff and DevOps. And today topic is trunk-based development. It's more DevOps topic. So I personally had experience with this approach working with client realtor.com. It's the biggest website for searching property to buy or to rent in United States. More than 300 million unique users per day. So it's pretty huge website. Yeah, and we implemented working on like another feature. We decided to try trunk-based development, and today I will tell what I've learned and why probably you should try it to adopt it. Okay, let's go. Let's describe problem first. What frustrates developers the most? What makes developers angry? And what reduces development experience? First is merges and merge conflicts. When you work with big projects and in companies and corporations and small, maybe even small projects that have version control system, where you create branches and develop. So you know that merges and conflicts is a pain, especially when you have huge PRs. So this is second thing that frustrates. It's huge PR that needs to be code reviewed, and when you have huge PR living in a separate branch, and when you try to merge it, you can have multiple merge conflicts, and you can spend lots of time resolving those conflicts. So another thing, back and forth between code review and PR. So when you created a PR, you need someone to go through code review process, and sometimes you can get some feedback to fix something, to fix code to be more quality code, to implement some best practices. So, and you need to do another commits to fix those, to resolve feedback, and then you need to find people and ask them to review it again, and they can find something else. You can so it can be a back and forth process for even multiple days or even weeks sometimes, depending on the PR. So flakiness, another thing that frustrates developers. When you finally get all the reviews, when you try to merge your feature branch, you can experience flaky tests and broken builds. So sometimes it can be really frustrating when you got all the reviews and you try to build on the pipeline the application, but it doesn't build for some reason. You experience some flaky tests. You need to fix those. Again, you need to do maybe some changes. Again, it goes to the third one, back and forth between code review and PR. So this thing called integration hell. And this is really frustrating, especially when you have PRs huge like this. Like you see more than 3,000 files change in this PR. This is really pain to review. So if you see this PR and teammates ask to review this PR, you would think, okay, I have another work to do. Maybe I work on another feature, so I don't have time. Please ask someone else, because nobody wants to review this amount of code. It's really a pain in the ass. And when you are trying to merge this PR, probably you will experience multiple merge conflicts that hard to resolve. Okay, so what's the process you probably all go through working on different projects? It's called Git flow process. So Git is a version control system where you like create branches, save different version of your application. So usually it goes like this: you create your local branch, you commit on regular basis to the branch while working on the feature. Once feature is ready, you run a series of tests, and if tests pass, you create pull request, and your teammates review the pull request. They do code review and everything. If everything looks good, you merge it to the main branch. So this is how it looks on the schema. So you have main branch, you create your own blue one, you work, you do multiple commits, then you merge to the main branch. So where the problem can come, when you have a big feature and you're working on it a long time. Let's see, for example, feature 1, it can take maybe months to implement. You create feature branch, which is not like which gets version of the main branch from this point when you create it, and you work on this feature for long time. Meanwhile, maybe another teammate working on another feature creates another feature branch and starting working on another feature, and maybe he or she finishes earlier because she's more productive, or feature is less, just smaller feature. So they merge their changes into the main branch, and then you finish your feature and you need to merge it to the main branch again, but you have old version of the application which doesn't have those changes, and you can experience lots of merge conflicts. And here comes hell, integration hell. So you can get merge conflicts. This is first. Second, main branch can change significantly, and your changes not reflects those changes, and your feature may be working nice on your branch, but it can be broken or working not as expected when after the merge. So you need to spend some resources on QA and bug fixing, and also merge conflicts can take some resources as well. Okay, here integration hell. So let's talk about disadvantages of Git flow. So it's slow. It can take days or even weeks to go from making a change to seeing it live in production. So as in this example, we can create feature branch, and it can take a long time before we do everything right, before we go all through all QA and the fixes. And when we merge it to production, then code review may take a long time and merge conflicts may appear. It's error prone. Again, as I explained, your branch may not reflect all the changes happening on the main branch. This is a simple example with two feature branches, but in real life, you can have multiple branches and people constantly merge into the master. They fix bugs, they do some improvements, configuration changes, and you have old version of the application. So you have no idea that those changes are happening. And so you can have multiple errors after merging your branch to, to the main branch. Okay, inventor of Git, Linus Torvalds, he says, if you merge every day, suddenly you never get to the point where you have huge merge conflicts that are hard to resolve. This is a very important quote, because this is principle of trunk-based development. So what he says, you need to merge every single day your changes, and you don't have merge conflicts that hard to resolve. So let's see two example. On the left, we see feature branch flow. On the right, we have trunk-based development flow. So on the feature branch flow, you create from the master, you create your own branch. You work long time on your feature, then you have huge PR, and here comes integration of hell. Trunk-based development flow, when you create your branch and you do small changes, you merge, you pull from the master, you do small changes, you merge, you pull from the master. This way you always synchronized with all the changes in the master, and you have very little, if any, merge conflicts, and it will improve workflow significantly. So what is trunk-based development? Trunk-based development is a methodology where developers work directly on the main branch of the code base, the trunk. No long-running development branches, so you don't create branches that lives long separately from the main branch. You're constantly merging. All changes are made directly on the trunk and deployed immediately. No feature branches, and you need to use feature flags. This thing is commonly used instead of feature branches. So let's say you work on feature that takes a long time. If you merge constantly, if you merge like every single day, definitely your feature is not ready yet, or even in broken state. How you make sure that it doesn't affect the main application, or it doesn't affect user experience? You use feature flags. So you need to abstract your feature the way you could implement feature flag, and you can switch it on or switch it off easily when you need it. So by default, it's switched off. Nobody sees it, no user. It doesn't affect the application in any way. You constantly merge into the application, but it doesn't affect the application. And when you're done your feature, you can turn on the feature flag, and suddenly a feature appears on the application. Users can see it, use it. Yeah, so this is feature flag. So as I said, we tried this approach in realtor.com. So this is another schema, how two ways of working looks like. So on the top, it's a Git flow process. So you create a branch, you write some code, you commit to the branch, then you merge to the master, creating pull request, and you need to go through code review process. The end. And in the Git flow, trunk-based development flow, you create a feature flag and you start developing on this feature. You write some code, you come into the master, and then you repeat. You write some code, commit to the master, write some code, commit to the master. And while feature flag is turned off, it doesn't affect the application. So again, about feature flags. Feature flag helps to deploy code that is not ready yet. What I mentioned helps to proceed with A/B test. A/B test is very important thing when you working with trunk-based development, it's good to try A/B testing. That's what we did in realtor.com. So how A/B testing works? You create feature flag, and by default, while you're developing it, it turned off. Nobody sees it. When it's done and it went through all the testing processes, and it's ready to go to production, you can allocate maybe 5% of your users to turn on this feature flag for 5% of your users. So 5% of your users will see this feature. After some period of time, this 5% of users will use the feature, you will have some feedback, and then you can turn it on for all the users. So this is how A/B test works. We used Optimizely for A/B testing, very helpful feature. Yeah, so feature flag also helps to share code between feature that is on progress, not ready. What does it mean? For example, you started working on the feature, and this feature requires creating some component. For example, let's say React component. You create this component, and it could be reused by other teammates, but they don't see your component until your PR is merged. They cannot use it. Here in trunk-based development flow, you create this component when working on the feature, you merge it, and other teammates can reuse this component already, even if your feature is not ready yet, but they can reuse the code that you created. So this is feature flag. Okay, advantages of trunk-based development. As I mentioned, trunk-based development helps to avoid integration hell, because you merge on regular basis. You don't have big PRs, you don't have big merge conflicts. In realtor.com, we even worked what's called extreme programming without any PRs. We just merge everything directly to the master. It's easy to find and fix bugs, meaning when you merge small pieces of code, chunks of code, it's very easy to debug, because you know what's new. You can debug the small piece of code, and it's definitely easier than debug the big feature that took months to write and has 1,000 files in it. It makes it easier to review code changes as there is less new code to review in each commit. Yeah, so again, if you merged on a regular basis small chunks of code, it's easy to review. So another advantages of trunk-based development. Usually when you're working on trunk-based development, you work closely with teammates to constantly doing code review, or maybe even pair programming. So pair programming is often used to enhance trunk-based development. So it improves communication in the team. Trunk-based development can help to get feedback faster on your change. Again, because you constantly merging to the master and pulling from the master, you get feedback on how your piece of code works in master, in like real scenario, in current version of the application. So it reduces the risk of project failure as any issue are found and fixed more quickly. Trunk-based development can lead to faster delivery of a new feature and improvements, as there is no need to wait for long integration and testing phases. Instead, changes can be released as soon as they are ready. Again, so you do some changes, you merge it. Do some changes, you merge it. Okay, but trunk-based development has disadvantages as well. So you may experience some conflicts. If you work on your branch more than like 1 day, you still can experience some conflicts. So solution for this would be to push small chunks of code. This is the principle of trunk-based development on regular basis, and do regular pulls. So another disadvantages is difficult to implement. To implement trunk-based development, you need good test coverage. You need to trust your tests, as you almost like don't do PRs and code reviews. Like you review small chunks of code, you need to trust your test to merge to the master on a regular basis. So it requires good pipeline configuration. Again, to make sure that only good quality code is got merged to the master, you need to configure your pipeline, include all the tests. You need to trust all your pipeline. You need to trust your tests to make it happen. You need to use feature flag that requires changes in infrastructure, and feature flags requires not only changes in infrastructure, it requires skills to build abstraction and decomposition. What does it mean? It means you need to have a skill to be able to abstract feature or piece of code you're working on the way you could implement feature flag to simply turn it on and turn it off easily. So solution for all these problems is splitting engineers to small teams and splitting large application to microservices and packages. It helps to resolve this problem. So trunk-based development is difficult to implement when team has hundreds of people and application is monolithic, not split to microservices and packages. So it's much easier to implement when you have multiple teams working on separate packages and microservices. So this is one of the solutions could be implemented with trunk-based development. So another disadvantage of trunk-based development is difficult to roll back changes. So each change is made directly in the trunk, and there is no separate branch for holding previous version of the code. Yeah, so again, let's take these two example feature branch flow. You create your feature branch, you do all the changes, and you merge huge PR. And if anything goes wrong, like you realize you messed something up, it's easy to roll back. You just need to roll back this commit that merges your branch. In the trunk-based development, you merge constantly, so there is no single point to roll back. You can roll back like separate multiple mergers you've done. But the thing is, again, if you use feature flag and abstractions properly, you would never want to roll back all the changes, because your feature shouldn't affect application in any way and shouldn't affect user experience. You just, if something's wrong with your feature, you just switch it off. Nobody sees it, and you continue working on it. You continue debugging it and fixing it. Yeah, so as I noted here, trunk-based development rarely requires something to roll back because of the feature flag nature. So again, to make sure you not mess something up, test coverage is very important, and continuous integration pipeline should be well configured. Despite these potential disadvantages, trunk-based development can be a very effective way to manage code changes and allow multiple developers to work on the same code base without causing conflicts. When implemented correctly, it can lead to faster development and fewer problems. It's true, it's what we experienced in realtor.com when we implemented trunk-based development. So one thing that's good to implement when working on with strong-based development, excuse me, it's pre-push pipeline. So to make sure that only good quality code goes to the master branch, we used Husky to create pre-push hooks. These pre-push hooks do all verification tests and check all pipeline builds and stuff like this before pushing. So if it fails on any step, you're not able to push if you're using pre-push hooks. So this way only if everything's good, everything's green in tests and pipeline, only this code gets pushed to the branch, to the main branch. So another methods that good to try when working on trunk-based development is pair programming. Pair programming is a method of programming where 2 or more developers work together at the same time on the same code. This can be done in person or over a video call. So what advantages of pair programming? So pair programming, when doing pair programming, people can share knowledge and ideas more easily. So usually it looks like this one programmer doing actual coding, another one gives ideas, doing live code review, look for any errors or best practices, and then they can change. So after some time, another person takes the wheel and start coding, and the other one shares some ideas. So again, pair programming helps to share best practices. It decreases learning curve for newcomers. So if you have new team member in your team, it's easier for them to learn the application and the way you work when you do pair programming with more experienced developer. It reduces the number of potential bugs. Again, because you have 2 pair of eyes looking at the same code, you will see bugs right away, probably. Not probably, it happens very often. Overall, pair programming improves quality of the code. Yeah, it improves quality of the code. It improves communication between developers and the team. And the huge one, no need for a code review, because you already have 2 pairs of eyes looking at the code. So you both make sure that everything looks good, that you used all the best practices, that you avoid all the bugs, potential bugs. So you basically, when you done coding, you done review, because pair programming is live reviewing at the same time. This is really helps to, like in our experience, it helped to remove PRs completely and code review completely. We use pair programming and no code review, no pull requests. We just do pair programming and then merge directly to the master using pre-push pipeline, pre-push hooks. So how to implement trunk-based development in your projects? So you need to choose the main branch. It's going to be the trunk. You won't use feature branches. You need to use feature flags. So you need to create, if you start working on the feature, first thing you need to create feature flag. Then you're working on the feature, you need merge pull changes on regular basis. You need test thoroughly. You need to believe, to trust your tests, and you need to trust your pipeline to make sure it catches any problem, any like test fails and so on. And yeah, practice pair programming with your team. This is Valley of Despair. Oh, sorry. Let me close this. So when first I was introduced to the trunk-based development in our project, I was shocked, and everyone in the team was shocked, because when you used to work with branches, multiple branches, feature branches, it looks like a very new approach of doing work. So you shock, and then you deny it. You say it's not gonna work. It's a bad idea. Please give me my branches back. I want to work with my feature branches. I don't want pair programming and stuff. So you resist, you become anger, and then you just let it go. You understand, okay, this is happening, this change happening, and you're just, okay, let's see what's going on. Then you try experiment and you anxious about it. Then you start getting some optimism and acceptance of the new way of doing it. And then you become enthusiastic. It's what happened to me. So I was shocked. I was in denial in all these steps, and now I'm enthusiastic about trunk-based development, and I think more people should try it because it really helps to improve development experience and quality of code and development time and the integration time. So again, we implemented it in realtor.com, and the result after 1 year of using it, improved development experience, improved communication between team members due to pair programming, improved code quality, faster development, less burns out, and almost no resources spent on merge conflict, build failures, code review, and flaky tests. Because you merge small chunks of code to master on a regular basis, you are less likely to experience all these bad things. In conclusion, I can just quote the data from Puppet Labs. In 2015, they stated the report that trunk-based development predicts higher throughput and better stability and even higher job satisfaction and lower rates of burnouts. So this is exactly what we experienced after implementing trunk-based development. Yeah, so this is pretty much it. Do you have any questions? Okay, if no questions, I will give you back 20 minutes of your time. Thank you for participating and good luck with your hacks. Bye.